favorite fraction busters. I know how you love them. Um, I saw a bunch of people started them already, and I really want to tell you how much I appreciate that. First, what's the least common denominator for number 6? 35. Excellent. So I'm going to go times 35. Make sure to times 35 on the B, times 35 on the 22, and also make sure to times 35 on the 1. So we have to be really careful, times 35 on everything. 35 times 79. It's going to be some gigantic number. And 35 times 22 is going to be some gigantic number. You guys have any questions about where my numbers came from? Okay, what do I do next after multiplying? Yep, 2765 divided by 35. I really shouldn't have to do that in the calculator. That's 110, right? How bad is this answer for those of you that already did it? It's not? Hmm. So divisible by 7, eh? So, quick question. How are these coming? Are they getting better? I hope so. Because they just don't go away. Like like a spaghetti stain on a white couch. That's a Friends reference. Anyone watch Friends? No, nobody. Just me and Miss Destiny. Okay. I need to live in a land where I can spin. Okay. All right. Least common denominator is 20. Thank you so much. Do you guys think I can do this one with no calculator? Do you think I can do it with no calculator at 8:43 a.m.? Okay, I'm gonna give it a go. I'm gonna be like my own America's Got Talent show over here. All right. So 20m minus 80 over 5 equals 20. Oh no. It's gonna have a it's gonna have a bad answer. I can already tell. Okay. Minus 80 over 5 minus 140 over 4. Okay, so do I want to actually, I don't even have to figure out what any of that is. It's just clearly a solution. Gosh, I was all ready to like do all this mental math and then just sort of didn't need it. Oh well. Okay, do not put your packet away, guys. Most of our classwork today is gonna be in your packet. You can find the resource page. It starts with number 42. So when you're ready, flip in your packet to find number 42. We're not going to start with this. We're gonna do this in a minute. So just find this and then set it to the side. And start with this first. So we're gonna do a problem before we do the resource page so that the resource page is much easier. Question. Last year, did you guys learn anything about sequences? Meaning number patterns. Did you learn about notation of number patterns? No, okay. So that's the part where I'm gonna have to teach you that before we do the resource page. I'm just honestly not sure what you know and what you don't. So I'm just gonna basically start from scratch. Are you all tired from the rain or because it's Thursday morning or because you got a big week this week or what? Are you all tired? I'm getting this tired vibe. I'm also tired, but it's because I haven't been sleeping well. I don't know what's happening. Like I go to sleep okay, and then somehow my bedroom becomes like 7 million degrees in the middle of the night, and then I wake up and do this like tossing thing. I don't even understand it. It might be because it's me and my husband and three giant dogs in there. I mean, it's a very good chance that that's what's going on. Did I tell you about my giant dogs? I did. So I have two golden retrievers and one lab. Why would anybody do this to themselves? You're wondering. Well, see, I had the two golden retrievers before I met my husband, and he had the lab and the cat. And then when we moved in together, now we have an unreasonable amount of animals. Um, but here, this is, I'm just trying to wake you up a little bit. Just, just, make math a little more fun today. So this is Mrs. Talbot in the middle of the night. I'm sleeping just fine, and then all of a sudden I have to pee. Yes, I'm recording this video, but it's fine, because you're all high school students. Okay, this is what happens though. It's gonna be funny. It'll make you have a better day just from this story. Okay, so I wake up and I'm like, oh no, I don't want to go. And then I like fight it for a while, but I don't sleep, like that whole like, should I go? Should I not go? Can I just go back to sleep thing? Okay, so what happens is I get out of bed, but there's a dog right here. So I have to do this thing in the middle of the night, completely pitch black. Then I get to the, okay, so that's the white golden retriever. Then I get to the end of the bed, where it's the very large golden retriever in between the bed and the dresser, and I have to do this. And then I get to this part where the lab is like laying up against the bed. And she, by the way, is a battering ram. So if she wakes up in the middle of the night and decides to turn around, she will throw her whole body into the side of the bed, creating like this jolt situation. So then I'm like, and then slide the bathroom door, slide it open. Now you want to see me go back to bed? Okay. Now it's funny now, but 2 years ago I had a broken femur. Uh-huh. Yeah, just let that. Just just let that. Okay. All right. Are you feeling better about your day now? What? Okay, note to self, do not tell second period funny stories about Mr. Sabbath's life. You made them feel worse. Okay. Okay, so we're going to put some notes down here in the bottom because this is the part I feel like you might not know anything about. So I need to explain some stuff. Sequences are number patterns. Sequence generator is the growth. Okay, now we're going to talk about two different types. We actually have three different types in this class of number patterns. And we're going to basically use your prior knowledge from the stuff that we've learned already this year to help you with your number patterns. Okay, so we're going to work on two different types of sequences. There's actually three. The other one is just going to be called neither. So either you have something where it's going in a line, you have something where it's going exponentially, and that's what we've been working on with the bunnies and the ball bouncing thing where we multiplied every time. And then we're going to have some that are weirds. Weirds are going to be called neither. They're neither of those two things. And what we need is some common symbols to use. So this is probably one of the confusing bits. Okay, so here are our symbols. N equals the spot the number is in. I'm going to refer to the spot very often. Now, Dylan, does the word spot make sense?
Spot.
So let me explain. This is -9 is in spot 1. -5 is in spot 2. -1 is in spot 3. 3 is in spot 4. And 7 is in spot 5.
No, Y and X.
It is. And so N for us is going to be X, basically. And you can put a little X right there. Okay. The next symbol that you need to know is T of N. T of N is the number in that spot. Which before now we have called f of x or y. So basically, all of the problems that we do here, we've been doing all year. It's just that they're going to have different letters in them. So linear ones, we've learned to be this. Exponential ones, we have learned to be this. This we did in chapter 2. This we just did over the last couple of days. Okay, now in sequences, they look different. So pick a little arrow here. This is called arithmetic. So a linear function is called an arithmetic sequence. That is not the word arithmetic. Don't say arithmetic when you see that. It's arithmetic. Arithmetic is an adjective. Arithmetic is a noun. Oh, the English language, so fun. Okay, now what we're gonna do is take this and change it to look like this. So T of n equals D n plus T0. This is still your growth, and this is still your y-intercept. Okay, now use your mathematic powers of that analysis. What do you think D stands for? Okay, let me show you the sequence again at the top. Look at the number pattern. What's happening to this pattern in blue? Yeah, it is by how much each time? Four. Okay, so the growth is 4. Now, what do you think D stands for? Growth? I'm on fire today. Nope. How far apart are the numbers? Close, closer. It's difference. The difference between the numbers is 4. D stands for difference. Okay, so exponential, it has its own deal too. Those are called geometric sequences. Mrs. Talbot, you're getting dangerously close to the bottom of the page. I know. It's fine. And this is still y equals ab to the x. It's just different notation for sequences. This is still the y-intercept. This is still the multiplier. But it looks different because it's a sequence. Okay, so once you have all this stuff, then we're going to practice. Okay. Okay, make me a little table. It says n, t of n. Actually, go down a little bit more. Okay, so 1, 2, 3, 4, 5, 6, 7. Okay, so in the first spot is -9. In the second spot is -5. In the third spot is -1. In the fourth spot is 3. In the fifth spot is 7. Yes. Yep. So what's the next one? What's the next one? 11. Great. And then what's the next one? Excellent. Okay. So first thing we do is make the table. Second thing we're going to do is plot whatever points will fit over here. So 1, -9, 2, -5, 3, -1, 4, 3, 5, 7. That's all that's going to fit on my little graph. Okay, now do not connect the dots. These are supposed to be discrete. Because these are number patterns, there are no numbers between these. So do not draw the line, do not draw the line, do not draw the line. Okay, next thing we're going to find is the sequence generator. And we already found that. It's 4. Okay, and this one is arithmetic. How can I tell that it's arithmetic? Yeah,
It doesn't look like it's going up like this.
correct. It's a line in the top, and you can tell it's going up for each time in the table. So arithmetic is going to be adding or subtracting the same. Geometric is multiplying or dividing the same. Okay, last thing, we're going to find the equation. This is hard. So this is where I need you to focus. The equation is T of n equals dn plus T0. Okay, we know T of n is just y equals, and then mx plus b, basically. The slope is 4, which is the common difference. N is x. Okay, here's a question. If I follow this graph back down, what would b be? Negative 13. So my equation is negative 13. Okay, this is what I like to do. I like to take a different color pen or something, and I like to draw a little arrow with a line right here. That helps me get my negative 13 to put as my y-intercept. I went down 4 from 9. I went down 4 from 9. These are all going up 4. So like up 4, up 4, up 4, up 4. So I went down 4. What? Yeah, to the start, exactly. Okay, everybody, find the resource. So slide this over, find the resource page. I'm going to help you get started. I'm going to refer back to that problem in just a minute, though. Okay, so for each sequence, determine the sequence generator and use it to find the next terms. Fill in the table. Fill in the blanks to the right of the graph. The first one is done for you. Remember, n is the term number and T of n is the value of the term. A sequence always starts with 1, so the first term of the sequence is T1. Graph each sequence, the x-axis is n and the y-axis is T of n. Okay, here we go. So what is happening in this sequence? Up by 3. So we're going to put D equals 3. Okay, next question. Is this one arithmetic or geometric? Arithmetic means adding and subtracting the same. Geometric means multiplying. Arithmetic. Okay, now there are some weird sequences on this resource page that are not arithmetic or geometric, and you'll just put neither. Okay, what's the next number here? 8, 11, 14. Okay, now 8, 11, 14. Okay. What is term 0? -7. You guys all see where the -7 came from? Okay. And so my equation is T of n equals 3n minus 7. I should have written that over here. Okay, last thing, I just need to graph the ones in the table. That's -4. That's -4. Okay, hold on. We're just gonna have to estimate that guy. Okay, now scroll down to B when you're ready. Because we have not done one of these yet. Yes, honey. Beautiful. Okay, so first thing you notice is that it's times 2. And what does that mean for us? That means that our sequence generator, the letter for it is R. Does anybody know? You're not going to know. It's ratio. Ratio is the reason that they chose the word R or chose the letter R. Okay. And so R is 2, and that makes this one geometric. Does everybody understand the difference between arithmetic and geometric? So adding and subtracting, multiplying and dividing. Okay. Now, next 3 terms, 24, 48, 96. Agreed? Okay. 24, 48, 96. Okay, now if you multiply by 2 to go down the table, what do you do to go back up the table? Divide. So what would this be? Excellent. Okay, now let's do the equation. We haven't done one of these yet. Okay, so it starts with T0. So start, multiplier to the X. No crap. I'm living in function land, not sequence land. And but can you visualize y equals ab to the x? It's the same thing. It's just that it's got fancy sequence notation. Okay, so last bit, I have to graph this, huh? 1, 1.5, 2, 3, 3, 6, 4, 12, 5, 24, 6 can't graph it, but I can definitely see the curve. Okay, before I let you go to work on this, I want you to look through all of the sequences on the resource page and decide if they're arithmetic, geometric, or neither. So before you do all the work, just look through them and write down arithmetic, geometric, or neither. So give you 3 minutes. Just look at each one, decide if it's arithmetic, geometric, or neither. And then I want to check those answers before I unleash you to work independently. Middle shelf, middle shelf. Okay, so let's go over what type they are so that I can feel confident that you guys can work independently. C is neither. Okay, what that means is I still want you to do everything except for find the equation. You won't be able to find the equation for this, not yet. Sequence generator, you can just write in words even. So this one is a weird one. This one is arithmetic. Did you guys get arithmetic? Okay. And this one is neither, which means you'll be able to do the whole problem except for you won't be able to find the equation. Does anybody recognize this, by the way? No, I'm gonna let you stew on that pattern for a little bit. I don't want to spoil it. Um, okay, this one, F, what do you think? Arithmetic, great. What about G? It's geometric. Okay, and I want to pause here. I just forgot the R. Geometric. Okay, anyway. Okay, so this one is dividing by 2. Can you tell that it's dividing by 2? Okay, instead of saying that, we're going to put times a half. You want to make your geometrics in terms of multiplication, not division. What's up? Are you thinking about the crazy number pattern? Yeah. Okay. What about H? Geometric? Oh, why can't I write? Um, Beautiful. Great job. Also, I need your help with something in a second. This one is weird. This is neither. And I would love to see if you guys can come up with the pattern. That one's hard. What about this last one? Yes, geometric. And this one, it's easier to find the multiplier looking further into the sequence than at the fractions, but once you think about it, it makes sense because this is 1.25 and 2.5. Okay, now 44, I've already embedded it into everything we did. So if you just fill out each one the same way we did the first two, you also will have 44 done. So you just need to keep going and doing the same thing. Starting here. And if there's some of them that you can't figure out the pattern for, talk to your group. Try to think about it before you just immediately ask me. Because I want you to think. It's much more satisfying when you figure it out. Okay, last thing. So you guys can work on this independently after this. Homework is 45 through 50 in the CPM book, and there's my joke. It says, I'm like 25% funny and 85% bad at math. That's why it's funny. So they prove the bad at math part and the funny part.